Welcome back, everybody. This is AP Chemistry. We're in Unit 9, and this is Section 3, taking a look at what happens when we titrate a strong acid and a strong base. We've been looking at equilibrium, we've been looking at buffers, we've been looking at all those things. Now we can mix acids and bases together in certain amounts and see the effects of that. So we're going to be taking a look at those titrations. Okay, so titration is a reaction of an acid and a base, and we add them together. Now, we've done titrations before, and so we can see some of these things along the way by using different indicators and so on. But this process, when we're doing an acid-base titration, is often monitored by plotting the pH of that as a function of the amount of titrant added. Such a plot is called the pH curve or a titration curve. So to set this up just a little bit of what we're trying to do, we're analyzing as we go. So let's take, for example, we have some kind of acid, and let's say that it's going to be a strong acid like nitric acid. Okay, so again, we're going to start with strong, and then we'll take a look at what happens when we have weak. Let's say we have, let's see, a 0.2 molar solution of nitric acid in here. Okay, and we have 50 milliliters of this. Okay, that's just sitting down in the bottom. And so what happens is we're going to be titrating in some strong base with it. So let's use, for example, the sodium hydroxide. Now remember, we have these burettes. They have the little stopper on here. We're going to be putting in this sodium hydroxide, and let's say that we know the concentration of it of a 0.1 molar. And so the question is, how much of this are we going to be dropping in to neutralize all this acid? We can do a lot of different things with this, but in terms of the reaction, we would be reacting my nitric acid with my sodium hydroxide, and what will end up happening is we're going to be neutralizing all of that acid at some point to sodium hydroxide, and we're going to be getting water with this. So if I was going to be really looking at this in terms of a net ionic, we're going to be extracting all my hydrogens and reacting with all the hydroxides, and I'm going to be getting water, okay? So that's the goal, to neutralize it all with this, okay? So if I take a look at it in terms of this, and I want to know how much, well, I see that I have, just kind of stoichiometry-wise, if I have 0.1 molar solution, that's 0.1 molar over 1 liter. And if I have 50 milliliters worth, that's a 0.05 liters worth. And so I would need to have 0.005 liters if I was going to neutralize that. Basically, that's how much I'm going to be having to add in. Okay, so that's the concept behind all of this. Now let's take a look at what is going on with a true titration, and how we would know we would neutralize it. It was we would put in an indicator like a phenolphthalein. That's going to be the pink stuff. Okay, so let's take a look at a scenario where we have 50 milliliters of this, and we're going to be adding in the sodium hydroxide. Now we're going to add this in different stages. Okay, and I'm just going to walk through each of these in turn. We're going to be seeing what happens to the pH as I add my sodium hydroxide in. So we're going to start with just no sodium hydroxide in the first place. Now remember, my pH is going to be the negative log of my concentration, okay? And I have, in this case, 0.2 molar. That's my concentration. So negative log of the 0.2 gives me a pH, a starting pH of 0.70. Okay, that's with no sodium hydroxide added whatsoever. So what happens then if I add in 10 milliliters, okay, of my sodium hydroxide? Now remember, my sodium hydroxide is 0.1 molar to begin with. And so my net ionic is going to be making my water. And so I started with, let's see, in this case, I started with a 0.01 hydrogen ion. Okay, how I got that was going to be 50 milliliters of my 0.2, so 0.2 over 1, and I multiply that by 0.05. That gives me a 0.01, doesn't it? Okay, so that's how many hydrogen ions are floating around in there. Same thing is going to be, now I'm going to be adding 10 milliliters of the 0.1, so that gives me a 0.001 of these, because this is 0.01 times the 0.1, that's 0.001, and I don't have any water to start with. Okay, so I'm going to eat up, this is my initial, I'm going to eat up some of these hydrogens 0.001. So I'm going to eat up some of those. I'm going to get a 0.001. Now, this is kind of a silly number to be working with because it's just water and he doesn't do anything. And so you'll notice that equilibrium, I saw that I ended up with 0.009 moles of my hydrogen ions. Now, here's where you got to be careful because we had 50 milliliters to start with, and I added 10 milliliters of this. So how many liters is that total? That's at 0.06 liters total. Okay, I ended up with 0.06 liters total. That gives me a molarity of 0.15. And so the pH is the negative log of the 0.15. So my pH, remember it started at 0.70. Now my pH is at 0.82. Okay, now let's add 20 milliliters of this. Well, what's that going to change? That's going to change this value right here, isn't it? Okay, so if this changes it to 0.02, this changes this to a 0.02, so this ends up being a 0.008 moles. Now, remember, I have 0.008 moles of my hydrogen ion, but now I have 0.07 liters total. So that gives me 0.1144 molar solution. pH is the negative log of that, so it's a 0.94. That's if I had 20 milliliters. So we started at 0.7, now I'm at 0.82, now I had a little bit more in there, now I'm at a 0.94. Okay, let's keep going with this. And so I have my letter D, I have 50 milliliters total. Okay, well, what does that do? Okay, let me just start. Here's my hydrogen, here's my hydroxide, here's my water, which who cares because it doesn't really do anything. But remember, I started with the 0.01, I started with a 0.002, okay, and now I'm at a 0.005. Okay, because I have 50 milliliters and it was 0.1 molar to begin with. Okay, so 0.005, I'm going to lose or eat up 0.005, 0.005 here. And so at equilibrium, I'm seeing that I'm going to end up with 0.005. Okay, because that's subtracting that off. Okay, so this is going to be a 0, and so it's now 0.005 divided by 50 milliliters here, 50 milliliters here, that's 0.1 liters here. And so then I end up with a molarity of 0.05 molar. Okay, so the pH ends up being 1.30 at 50 milliliters. Okay, now also let's take a look at the next one. I'm going to be adding in, here's my hydrogen, here's my hydroxide, okay, my water. Keep these all straight. And so again, I started with the same amount, and this time I had 0.1 liters worth of 0.1, okay? So that gives me a 0.01. And all of a sudden, I see my hydrogens and my hydroxides have equaled one another, okay? Once we see that they're equal to one another, this means I hit my end point. Okay? It just means that I'm going to totally neutralize everything here. So I end up with a 0.01, subtracting that off. And so the change is this: at equilibrium, I don't have any more hydrogens and I don't have any more hydroxides. Well, what's the pH when the hydroxides equal the hydrogens? Well, the pH is going to be 7. What a huge jump we had from just adding 50 more milliliters in. Okay, now if I've hit my end point, I know that I'm going to end up with a pH that's going to be above that 7 point. Okay, so let's just take a look at what happens when I add in 150 milliliters total. Remember, that's 0.150. And so my hydrogen, this is the last one I'm going to be doing, hydroxide, I'm going to be making my water. Okay, and so I started with a 0.01 here. 0.150 times 0.1 gives me a 0.015. And notice now I'm going to have more hydroxides than I have with hydrogens. So now it's the hydrogen that's going to be eating up my hydroxides. Okay, so it flipped, didn't it? I saw that I had more hydroxides, so at equilibrium my hydrogens are gone, and I end up with 0.05 moles of hydroxides left. Now be careful because I'm not done. I don't have 0.05 molarity, I have 0.05 moles. How many total liters did I have? Well, I have 0.150 milliliters here. I have 50 milliliters here. That's 200 milliliters. So I divided by 0.2 liters. And so I end up with my hydroxides now being 0.025 molar. So pH is the negative log of that, and I end up with a pH of 12.4. Okay? So, and I guess I should clarify with that. We would, if we do my pOH with this, that will be the negative log of my 0.025. My pOH would end up being 1.6, and how I got the 12.4 is I go 14 minus my 1.6, and that's what gives me my 12.4 with that, okay? So just to clarify on there, we found hydroxides. We would technically be finding pOH, and then we would subtract from 14 to get my 12.4. Again, look at that huge jump because we never did calculate what the strength of this would be in the first place. So that's a titration curve, and if we're plotting these out, that's what we're going to be doing in lab. You'll be able to track those pHs as we go, looking for the end point, and that's the tipping point where all of a sudden the hydrogens are going to start taking over the hydroxides. Okay, so that's the end of this section, and we'll be doing lab with it, and titration curves are kind of fun. All right, good luck, guys.